I've had some of these 8x8 dot displays hanging around for a while, and I didn't yet try to use them, so I thought I would do that today. So these displays, so you've got 8x8 dots, as you can see. There's a chip there to drive them, which is called the MAX7219, and we'll have a look at the data sheet in a minute to understand that a little bit. I want to use this Arduino clone again, so the Arduino Mega 2560 that I've used successfully a few times. It's a nice compact unit. And so the way that these work is they're basically all daisy chained together. So this right hand side gets connected to the microcontroller, so the Arduino in this case, and it sends the data in through pins here, and then we interconnect them so that this side also has the data bits clocking out, so we go from out to in on the next one. So basically we're daisy chaining them in this direction, and we've got one set of data bits that are traveling this way along the display, and that allows you to basically add as many of the displays as you want to make an arbitrarily long line. So I've got 6, so I've screwed 6 down here. Now let's have a look at the data sheet. So the MAX7219, so the idea behind this is it has quite a simple interface to the microcontroller. So it uses this bus called SPI, and so you've got this pin MOSI, which has got the data bits on it. You've got this pin here, chip select. So you have so that the chip select allows you to have multiple devices all connected on SPI basically. And then you have a clock, so the clock pulses say when the data is valid on this pin. And you see here, for the sake of illustration, they've got 7 segment displays, so you can find different types of MAX7219 displays which all have the same chip built in, but some of them are 7 segment displays and some of them are 8x8 dot matrix like this instead. And if we have a look at this illustration from the data sheet, it's quite interesting. So you can see here you've got the D in here, and you've got D0 to D15, so that's 16 bits. So you have to clock out 16 bits in order to show one thing on the display. And the 7219 has got all of these registers, so it clocks in the bits and stores them in a register, and then it allows you to drive the rows and columns of the display. So what the other thing I wanted to point out is that as well as the D in, where the clock bits get rolled in, you've got a D out. So then this is the output, but 16 bits behind, if you like. And having a D in and a D out means that you can then put another 7219 daisy chained in front of it, and then if you clock out 32 bits, then you end up with the first 16 bits in this unit and then the second 16 bits in the original unit. So this would be the right hand most unit in my setup here. So what we're going to do is we're going to connect all of these displays so that we've got D in connected to D out of the next, and then the rest of the pins can actually be in common. So the chip select and the clock and the ground and the 5 volts is all going to be in common for all the displays. So I'll do a bit of wiring and then we'll have a look at the Arduino script that we're going to use to drive the displays. There are some quite good libraries that have already been written, so I'm going to use an existing Arduino library. Right, so I've done some wiring up. I'll just describe that for you. So starting off with the clocked data, so this is these blue wires are what are connecting the various displays together. So here we've got the D out here, the data out. It's been wired round to the data in of the next one, and you'll see that's the same across here. So each D out is connected to the D in to the left, and all of the rest of the wires have been looped from one display to another. So we've got red for 5 volts, black for ground, and then have a look at my little cheat sheet here. Yeah, so the chip select is white and the yellow is clock, because those can all be in parallel. So the important one to have daisy chained is this D in, D out. And then on the connector here to the Arduino, we can look at this little chart that I put together. So we've got so the display is marked up like this: clock, CS, D in, ground, VCC, and we just need to make those match up with the correct pins on the Arduino. So the S clock and MOSI are SPI pins, and on the Arduino 2560 Mega 2560 Pro that I've got here, there's a little bunch of 6 pins here where the SPI bus comes out. On standard Arduino Uno, they're kind of edge pins. And then you see I've got the orange connected onto D7 there, which I just kind of picked at random. It doesn't really matter which one you use for the chip select. You just got to make that match in the software. So I picked D7 because it was a short distance for that cable to go to. So just leave that on the screen for a second, and if you want to build the same, you can freeze the frame and reproduce. So you see I've got quite a simple script running. It's just sort of writing this script on the left and then on the right. So let's have a look at that. So first of all, I'm using this library called Parola, which seems to be quite a sophisticated, all singing, all dancing library for these kind of displays using the MAX7219. So I just kind of cut bits out of an existing script to try and make this as simple as possible. So important things here are, so I changed the hardware type to generic hardware. So this type of display with the dual inline chip visible at the top, this is what the Parola library refers to as generic hardware. So I've selected generic hardware. If you select Parola hardware, then what seems to happen is it actually writes the display up the other way at 90 degrees. So if that happens to you, then obviously you'll know what's going on. So I've set the max devices to 6 because I've got 6 displays, obviously, and I've selected my chip select to be pin 7. That's the D7 pin. So so this is the line here where we actually declare the display. So we create this object using the class MD Parola. So disp is going to be our display, and we pass in the various parameters to make that create attached to the right thing. You can, so with this structure you can drive several different displays at the same time. So there is an example, there's a Parola example where there are two different displays, and they're basically making two lines of text using two sets of displays. But I've just got the one. So in the setup, so I call this begin to initialize the chip. Intensity sets the brightness on the display, so 5 is pretty good, and then I'm clearing the display. And then in the main loop here, all I'm doing really, I've got some text here, so it displays the text for 2000 milliseconds, and what this is doing here is it either aligns the text on the left or on the right, depending on whether this count is odd or even. So I'm incrementing the count, and if it's odd I'm doing one thing, and if it's even I'm doing another. So that gives the alternation between left and right. So if I compile this now, so I've changed the string to greetings, you can see what that will look like. Right, so I can see the LEDs flashing on the Arduino, and there we go. So now we've got a different string. Now there's a lot of different examples in this Parola library, so if we have a look under examples, you see there's an awful lot to choose from, but they don't all apply to this type of display. Some of them are for the 7-segment displays, and some of them need other hardware like switches, so we can't use them all. But one that looks quite good, let me just demonstrate that. I think it was this one, Parola zone time message. So we'll look at this one. Oops. Right, so we have to make a few small changes in here. So again, we'll change this to generic. And our chip select is pin 7 rather than 10. This is the MOSI and S clock, but we don't really need those because it's in actual fact it just passes in the CS pin, and the others are default. You see there's this other format that's been commented out that allows you to customize all the pins, so we don't really need that. And you'll see this has got information about, it's got some sensors integrated. So there's a DHT11, which is a temperature, I think barometric pressure sensor. I've got one in a box somewhere, but I can't be bothered to plug it in now. We'll just see how this goes. And the DS1307 is another sensor. That's a temperature sensor, a digital one. And so what else do we need? Oh, max devices. Did I set that? Max devices. Let's just set that to 6 so that we know that it's correct. And we'll compile that. That looks slightly freaky, doesn't it? It's doing something on the right hand side of the display there. Oh, this is the time, I see. So this is the time, and then it's scrolling some other information. One more example. This one's quite nice. So this is an example of animation. So again, I've changed to generic hardware. Max device is 6. Our CS pin is 7. And this is going through various types of animation that you can do with the display. So let me just compile that again. It's just resetting now. So it's just running through a demo of the various nice things it can do with text and sprites. Pac-Man there. So there we go, that's the MAX7219 controlled display with these 8x8 LED matrices, and using my Arduino Mega Pro again. So thanks very much for watching. See you in the next video.